Okay, one very important thing for applications is linear interpolation. Now that sounds way fancy, but really all that it is this. When you're given 2 points, you find an equation for a line that goes to those 2 points to get the specific coordinates of another point. So it's a nice tool. This is very important and very useful in applications where 2 quantities, 2 numbers in an actual application maybe are what are considered linearly related to each other. At least that's what the model would say. So to begin with, we're going to do a math-only problem and then bring in some applications after. So let's, just to warm up, consider the line that goes to the points 2, 5, and 6, 12. Then on this line, there's a point on the graph, on this line that has x coordinate 10. So what is that point? So let's just first of all make a game plan for what's going on here. Well, let's deal with the first sentence. There are 2 points, right? The point 2, 5 and the point 6, 12. Let's create an equation for that line. And then after that, we're going to deal with x equals 10 somehow. So we just need to create an equation for a line going through 2 points, compute the slope. Yeah, change in y over change in x, so 12 minus 5 over 6 minus 2. And in point slope form, which is going to be easier here, to be really honest, right? Here's an equation for the line using the first point. So y minus 5 equals 7/4 times the quantity x minus 2. Now, what point on this line has x coordinate 10? Right? That we need to bring in x equals 10 now. So now that we have this line, what we can do is ask this question and, well, recall first of all that a point is on the graph of an equation if xy satisfies the equation. So we're trying to find a point that satisfies this equation here, but we also know about the point that the x coordinate needs to be 10. So why don't we plug in x equals 10, and then, sorry about this typo 3, we'll plug in x equals 10, and then we'll just figure out what y has to be from there. We'll just recover the value of y. So plug in 10 for x, and then let's simplify. 10 minus 2 is 8. On the right side, you still have 8 over 1. So the factor of 4 on top and the factor of 4 on bottom cancel. You're left with a 2 in the numerator. 7 times 2 is 14. Then add 5 to both sides. So for a point on the line when the x coordinate is 10, the y coordinate has to be 19. Therefore, the point on the graph, or the point on the line, where the x coordinate is 10 is the following point. It is the point 10, 19. Let's see a picture of this. So the information we were given in the problem were these 2 points, and we created the equation, or an equation for the line going through those 2 points. And then we eventually, in this, said, okay, we're looking for a point where the x coordinate is 10. That's over here somewhere. And we did this all without using this graphing tool, but just to verify what's going on, we found that there is one and only one point where the x coordinate is 10, and we solved for the value of y and found that y should be 19. So this point 10, 19, let's turn this on, should be on the graph, and it is right there. Okay, let's do another one. Say the graph of a function called f of x is a line. So we're told that the graph is going to be a line for this function, and is known to go through the points 3, 8, and the point 9, -2. Then find f of 7. So this problem is formulated and put in the language of functions a little more, but it really is morally the same type of problem as what we were just looking at. So first, let's make an equation for the line going through the 2 given points. So compute a slope, and an equation for the line would be y minus 8 equals -5/3 times quantity x minus 3. Okay, let's, though we didn't do this last time, let's actually solve for y. So we just need to add 8 to both sides, and you get y equals -5/3 times the quantity x minus 3, then outside of parentheses plus 8. Now, the reason to solve for y here is because this is f, right? So we're going to replace the y with an f of x. Very often we go backwards from this. You have an f of x, and you just call that a y. Now we're just kind of going backwards with that, replacing y with f of x. So here's a formula for the function. And now based on this, to find f of 7, all we got to do is plug in 7 everywhere we see x. And yeah, OK, let's go ahead and simplify this a little bit here. We're going to get 4/3. So basically, let's try to summarize what happened here. We are done with the problem. But what really happened was, first of all, we found the line going through 3, 8, and 9, -2. Right? And we found that in that line, there's a point on this line with x coordinate 7, and that point has y coordinate 4/3. Let's see a picture of this. All right, so we were given the point 3,8, given the point 9, -2. We created an equation for that line, and then here it's written in a, it looks very reminiscent of that point slope form, but we did that add 8 to both sides, and if we wanted to, we could call this just the name of a function. That'd be all the same here. And then on this line, we're looking for a point where the x coordinate is 7. And let's see, where is that? So the computer tells us it's the point 7, 1.333, so probably 1.3 repeating, but we had actually computed it by hand without the calculator, and our exact way of writing this was a point 7, 4/3, which we had here. Yeah. So we're really making use of this idea that there's a function, which is written in notation, and then there's the picture. And because f of 7 is 4/3, that means the point 7, 4/3 is on the graph, as we see right here. OK, now let's apply this. So the last two examples were all just math only. But what really happens is something like this. So suppose the relationship between the number of pizza toppings and the price of a pizza is linear. So at a pizza place, which has 30 possible toppings, if a pizza with two toppings costs $12.50 and a pizza with 5 toppings costs $13.60, then how much is a pizza that has every topping? And then just so that we can avoid some arithmetic nonsense, let's just say do not simplify, but include units. All right, so we should really, this is the same deal as we just saw, just with some words to interpret, but we should create an equation for the line that goes through 2, 12.50 and 5, 13.60. So, okay, slope, change in y over change in x. Create an equation for the line. This is in point slope form. And it will help us out if we probably add 12.50 to both sides so that we have y solved for, so that y is all by itself on one side. We could even name that a function now, right? So f of x equals 1.10 over 3 times the quantity x minus 2, close parentheses, plus 12.50 represents the price of a pizza with x toppings on it. But then we can now find out, what about a pizza that has all 30 toppings? So we just need to compute f of 30, right? So then this number here, all we did was replace every x with a 30 without worrying about simplifying. This number could certainly be punched into a calculator or whatever, and this in dollars, there's the units, represents the price of a pizza with all 30 toppings on it. Let's do another example. Suppose that the relationship between the number of YouTube computer tutorial videos watched by a person and the number of minutes it takes them to install new software is linear. So if somebody who watched only three tutorials needs a hefty 55 minutes to install new software, and somebody who watched many videos, 20 tutorial videos, needs only 4 minutes to install new software, so that makes sense. The more videos you watch, you don't need as much time. Then how long would it take somebody who watched 11 videos to install new software? Again, we're making this assumption that this relationship is linear. It's maybe something like that. And so there's the person, kind of the inexperienced person who's only watched 3 tutorials, and the very experienced person who's watched 20 tutorials. And now we're trying to talk about, you know, somebody whose kind of experience is somewhere in the middle, has watched just 11 videos. So we're going to make use of this linearness and do the interpolation. So let's just, to be clear here, let's have x represent the number of tutorial videos watched, and y will represent the number of minutes necessary for that person to install software. So based on that x and y, we have, from the first part of this sentence, we have the point 3, 55, and from the second part of that sentence, we have the point 20, 4, right? So the order we're trying to keep here, number of tutorials watched, comma, number of minutes needed to install software. So we should create an equation for this line, compute the slope. Here we have in point slope form using the first point, 3, 55. By the way, the slope is negative here. I hope that makes sense, because the more videos you watch, the less time you're going to need to install software. That's the idea behind this, to make this a little more realistic. Let's solve for y. Just add 55 to both sides. And then we'll name this f of x, right? So here's our function. This function here represents the number of minutes necessary for somebody who's watched x training videos. Then, for somebody who's watched 11 videos, then what we're looking for is f of 11. So just replace all the x's with 11. And so somebody who's watched 11 videos, training videos, is going to need negative 51 over 17 times the quantity 11 minus 3, close parentheses, plus 55. That many minutes, that's how many minutes that person would need. Again, there's some assumptions going on here in saying that the experience based on watching computer training videos should be linear to the amount of time it would take to install a new piece of software, and maybe that assumption's a little wrong, but that's the model that we're working off here.